Welcome back for another edition of College Mathematics. And today is the day we start talking about sets. Okay. And I'm going to relate back to all those things that we talked about earlier. But as far as sets, I mean, today is the day we start talking about Venn diagrams and how the sets react to those. So before we actually jump into Venn diagrams, let's talk about some things that you need to know. So right here, I've given you a picture of Venn diagrams. Okay. Most of you have seen a Venn diagram that looks like this. So there's just some things that I want to talk to you about. So the first thing is what we call the universal set. Okay. This giant U right there, that's the notation for the universal set. And what universal set means is that it is a general set that contains all the elements under consideration. So inside here, inside this black rectangle, that's what we call the universal set. And that universal set could be like, say we're talking about all Valencia College students. So that would be our universe. And then inside here, we've got these other sets that are represented by circles, which is the circle A, and that's a set, and the circle B, and that's a set, because we got those capital letters. So circle A right here, since we're talking about Valencia College students, we could let set A right here be students with glasses. And then we could let set B over here be students in Mr. Armstrong's college mathematics course. So again, these sets A and B are actually subsets of the universe. That's why they're inside the universe, because the students that are in A, those that have glasses, and the students that are in B, those that are college mathematics students, they're all subsets under the universe, because all of these students in A and B are students of the university. So when we represent subsets, we draw them inside the sets that we're dealing with, or in other words, inside our universe. Okay. So wanted to give you a little bit up on that. And then now as I expand that over so you don't see all the good stuff coming up. So that's what the universe is. The universe represents this giant rectangle, and it represents all the elements that we're going to talk about. Okay. Some of them could be in subsets. Some of them don't have to be. All right. So the next thing we want to talk about is that we have a complement. Okay. A complement means that we're going to talk about all the elements not in set. Okay. Or in this case, I said set A. All right. Complement looks like this notation, an A with like an apostrophe. Okay. And it doesn't just have to be A, it could be set B, set C, it could be any set that we talk here. But what the fact of the matter is, when we talk about a complement, it's like kind of like what Thanos did at the end of Infinity Wars. Thanos snapped his fingers, and all of this set right here disappeared from existence. So the complement would be everybody that's out here that didn't disappear because of the snap. That's a complement. So everything that's in blue is what we would call the complement of A, because everything in blue is not in the circle A. Okay, and that's what a complement means. Give me everybody else but this set. All right. So think of a complement kind of like a snap. We're getting rid of one whole set altogether. And it could have been B. We could have gotten rid of all of B. And then the complement would have been everybody that's out here, including a little bit of this A circle and everybody that's down here. Complement of B is like we get rid of the entire circle B. It no longer exists for us. All right. Next one that we want to talk about, I can kind of slide this over because I know there's nothing below it, is intersection. Okay. Intersection means we want all the elements in A and B that are the same. So what is in common in these two sets? So again, when I went back up here, remember I said set A was all the students in Valencia that had glasses. Set B was all the students in Mr. Armstrong's college mathematics course. The intersection of that would be right in here. So in other words, I would want to know who are all the students that have glasses and are in Mr. Armstrong's college mathematics course. That's the intersection, and that occurs right here. So an intersection, think of where the two circles overlap each other, because this is where they both have glasses and college mathematics with Mr. Armstrong in common. Okay? So intersection means what do both of the circles share? And then last but not least, union. Union means give me everybody. I want everybody that's involved. So union says give me all the elements in set A, set B, or in both, which means the intersection. So union says we're inviting everybody to the party. Okay? So this is A union B. This is A intersect B. Okay? So notice the difference. Intersection is an upside down U, or sometimes I call it an N. And then the U is for union. Union. See, they match. All right. So if I come up here and I say, what is the union between A and B? That means I want everybody in both of these circles. And it's okay if they overlap. Bring the overlappers. Okay? So this right here, that's a union. All right? So union means everybody in both of these sets, even if they overlap. It's all cool. We're inviting everybody to the party. That's the idea of a union. Okay? So what we're going to do is we're going to be asking you guys to find me the roster of a set. For instance, skip that. So I want the roster format of A intersect B. I want to know what elements are in it. That's the goal of what's going on in 2.3 and 2.4. Okay, we'll get to 2.4 here in a second. So I have devised for you Mr. Armstrong's order of operations Venn diagram style. So these are the way that I would attack order of operations for determining the roster of a set. Okay? When dealing with sets and intersections and complements. First, deal with the parentheses. Take care of everybody inside the parentheses first. Then, take care of your complements. And then take care of unions and intersections from left to right. Just like normal order of operations. We always work left to right. Okay, so these are Mr. Armstrong's order of operations. I promise you, if you follow these 3 steps, you will be able to tell me the roster of any set given to you. Promise. Okay, so let's do it. So what I'm going to do is I'm going to split this page so we can see both of these. Okay, we'll pin this page in place real quick. So let's talk about these 4 pieces right here. Okay, I'm going to do number 1 with you, and I'm going to do number 3 with you. Okay, before I attack this, we need to get the Venn diagram for it. Okay, so we've got a universe, and then we've got a set A and a set B inside there. So let me show you what this looks like. I'm going to take it out of that dual page real quick. So kind of matching what I did earlier, I'm going to draw my rectangle. There's the universe. And then I have a set A. I think it was green, but it doesn't really matter. And then I have a set B. So whenever you're making Venn diagrams, you start in the middle. You start right here and you work your way out. Okay? So when I start here in the middle, I need to know what's in common between A and B. So what do these 2 sets share? So they don't share a 3, no 6. Hey, there's a 9. They share that. And there's an 11. So I'm going to put 9 and 11 in the middle, and I'm going to cross those off. And I'm going to cross them off on all the sets because we're not going to go back and grab those anymore. We've already placed them. Okay? And then now we're going to work outside of that. So right in here it says, well, tell me what's left in A. So we go back up to A and we see we have a 3 and a 6. So inside this circle, I'm going to put a 3 and I'm going to put a 6. So I'm going to cross those off. Forgot to do that. So we no longer have 3 and 6 and 9 and 11. It's all gone. So over here says, give me everybody that's left in B. Well, that's 15, 18, and 19. So I'm going to come in here and say 15, 18, 19. Cross those off. So I've taken care of A, B, what they have in common. Now we're out in the universe. So do we have any numbers that exist out here that are not in A and B? Absolutely. We've got two numbers right here, 22 and 26. So those numbers are in the universe. And this is our Venn diagram. Having a Venn diagram makes it a heck of a lot easier to see what's going on. Okay? So now I'll go back to my split screen. There we go. So let's answer this first question. So the first thing says, do we have parentheses? And no, we do not. So we move on. Do we have any complements? No, we do not. So we move on. Do we have an intersection or a union? And yes, we do. We have this guy right there, which represents intersection. So we want to know, what is the set, or in other words, what are the elements that A and B have in common? Or in other words, where do A and B overlap? So here it is. So the roster, or the answer, will be 9, 11. And again, it doesn't matter the order, but I do like to put stuff in order when it comes to numbers. So 9, then 11. And there's the answer. That's all they're looking for. Okay? Now, let's take a look at this guy right down here, this third one. Let's use my order of operations. So the first thing says parentheses. Well, there are no parentheses here. Second one says take care of any complements. Do I have a complement? Absolutely. Right here, I have a complement. So I need to figure that set out first. So I'm gonna ignore everything else over here, and I want to know what is the complement of A. So I need all of the elements that are not in my red circle A up there. So if you see right here, inside my red circle are 3, 6, 9, and 11. Yes, I know 9 and 11 are also in B, but because they are inside circle A, remember, we have snapped them out of existence. So 3, 6, 9, 11 no longer exist. So what are all the elements that are in the complement of A? Well, there's 15, 18, and 19, because these three numbers are not in the circle A, and 22 and 26, because these two numbers are not in that circle A. So 15, 18, 19, 22. Oops, messing things up a little bit. Let's fix that. Come on now. Oops. Come on. You got this. There we go. 22 and 26. I know Mr. Armstrong's hieroglyphics sometimes get the best of him. If there's something that you can't read, please always email me, ask. I'll always talk you through my interpretations of numbers. So there we go. This right here represents the complement of A. And now we move on, because we took care of the complement. Now we're down here. Do we have unions or intersections? And here we have a union. Now I'm going to write down what B was, just to remind us. Remember, B is 9, 11, 15, 18, and 19. So what they want us to do, remember union says give me everybody. We want everybody in red and everybody in green in one set now. That's what union means. Give me everybody in the red, give me everybody in the green, and that's who we care about. So our answer to this, what is the complement of A union B? Well, the complement of A union B, we have 9 coming from the green, 11 coming from the green, and then 15, which is in both of them, 18, 19. Again, these three numbers were in both of them, 15s, 18s, 19s, and 22 and 26. This represents the answer right there in purple. So the set of 9, 11, 15, 18, 19, 22, 26. Because again, union means give me everybody in both of these. Okay? And that's it. Go ahead, try B complement and the complement of A intersect B. Try those. Pause the video and go. Okay. So B complement, this guy right here, just means give me everybody that is not in B. Because there were no parentheses, there's no union intersect, you're just focusing on the complement. So if we look up here, I need all the numbers that are not within the green circle. So what numbers are not within this green circle? Well, that's 3 and 6, and 22 and 26. Those are all the numbers not in my green circle. And that's what a complement is. It's like we snapped them out of existence. Okay? So there's the answer. This is the complement of B because 3, 6, 22, and 26 are not in the circle B. All right, down here at the bottom, let's talk about this guy. So again, the first things first. Do we have parentheses? Yes, we do. So just like what you do with PEMDAS and normal algebra, we're going to do the same thing with Venn diagrams. We're going to work inside here. So inside my parenthesis only, this guy is outside the parenthesis. So inside my parenthesis only, do I have a complement? No. Again, I just said it. This complement is outside the parentheses, so you can't touch it yet. We have to do parentheses first. So we don't do with the complement, but do we have a union and an intersection? Absolutely. They want the intersection of A and B. Okay? So if I write down the intersection of A and B, we already know that answer. We did that right here. Here's the intersection. Remember, intersection just means what do they have in common? So the intersection of A and B are 9 and 11. So we've taken care of parentheses now because that was everything that was inside the parenthesis. So now what we want to do is we want to restart our order of operations, but now we are outside the parenthesis. Okay? Just fixing my letters here real quick. All right. So when we restart, do we have a complement now? Now is when we deal with the complement because again, we've already done everything inside the parenthesis. So now we deal with the complement and you won't have to worry about the last step because all that's left outside the parenthesis is the complement. So we want to write down the roster for all the numbers that we did not list here. So we listed 9 and 11. I need all the other numbers. So when we're looking at this thing, it's like we have snapped the intersection out of existence. So this 9 and 11 right there, gone. Okay? So we've snapped them out of existence. All we need to do is write down what are the numbers that are left. Well, we have 3, 6, 15, 18, 19, 22, and 26. Oops. $26. And that is the answer. Okay? Hopefully this is making sense. You're following along. I do like to show a little bit of work. Reason why I show work, I mean, some of these right now, yes, we could do in our head. But when we get into 2-4 and things like that, it's a little bit tougher to do all of it in the head because they're going to get longer. Okay? And you're going to see that actually here in just a second. So if you have any questions, come email me, text me, come to one of our Zoom sessions and we can talk more about unions and intersections with Venn diagrams and stuff like that. I can always do more. So like I said, this is where we're going to, we're almost done with this section, but I changed it up. I've got a new universe, a new A and C. Go ahead and try this on your own. Make the Venn diagram and answer these 3 questions. Okay. So I draw this up here. I draw my Venn diagram down here. Actually, I should do this in black so it kind of matches everything that we kind of been doing. So black. So this is my universe. And then I've got 2 circles. Set A. And this time it's set C. So again, remember, we always start in the middle. So what do A and C here have in common? Well, they have a 1 in common, a 4 in common, and the 8 in common. So I'm going to put a 1, a 4, and an 8. Cross those off because we will not use those again. Okay? Now, right here it says, tell me what's left in A. So the only thing left in A is 3. Cross it off. Over here is tell me what's left in C. So the only thing left in C are 2 and 5. So we'll cross those off. 2. Oh, no comma. I've got lots of room. And 5. So is there anybody left out in the universe? Well, if we see what's left after we crossed off, yes, we do have some people out in the universe. It's 6 and 7. So there is our Venn diagram. Now we can answer questions. So let's start with this one right here. So A, union, C, complement. Kind of like what we just did a second ago. So the first thing that we're going to deal with is we're going to deal with this A, union, C. Because if we look at our order of operations, it says parentheses first. And we have parentheses here. And then it says complement. Well, we can't touch that complement. It's outside the parentheses, so we move on. And we deal with union and intersection. Because again, this complement is outside the parentheses. And the first thing we deal with is inside the parentheses. So that's why we're going to do A, union, C. Remember, union says, give me everybody in these 2 sets. So the union of A and C would be 1, 2, 3, 4, 5, 8. Because those are all the numbers that are in the circle A and the circle C. 1, 2, 3, 4, 5, and 8. Now that we've taken care of inside the parenthesis here, now we will work outside the parenthesis and we rerun PEMDAS. So we've taken care of parentheses. Next thing is complement. We definitely have the complement out here. And complement means give me everybody that we didn't talk about here. So I want any numbers we did not list off here. That's going to be the answer. So I've taken care of 1, 2, 3, 4, 5, and 8. So that means the complement wants these 2 numbers, 6 and 7. because those are the only two numbers that are not in here. And that's what complement was. Give me everybody not in that set. Okay? And it's okay that the set is a little bit bigger. That's all right. So the answer to our first question up here is 6, 7. All right. Let's go ahead and jump down to this one right here. So A intersect C complement. Give me a second. Oh, nope, need to expand. So A intersect C complement. So if we run our PEMDAS, we don't have any parentheses. Do we have a complement? Absolutely. We've got the C complement. So we need to run the C complement first. So I need everybody that is not in the green circle. I need everybody that is not in this green circle. So what numbers are those? Well, that's 3, 6, and 7. Okay. So now we've taken care of the complement. Now we want to do union or intersection. And we have an intersection this time. Okay. So if I write down what A was, so remember our set A up above, just taking this from what I already know, is 1, 3, 4, and 8. Okay. Because again, remember that was right up here at the top. A is 1, 3, 4, and 8. I just rewrote that so I can look at it down here. So intersection means what is in common. Trying to get this to scroll down. There we go. Well, sort of. So what is in common between these two sets? What does the C complement and the A have in common? Well, in the end, there's only one piece. They both share 3. So the answer to A intersect C complement is just 3. Okay? Because that's the only thing these two sets share. The 3 and the 3. All right, last but not least, we've got this A complement union C complement. A complement union C complement. So again, I find A complement first, or you can find C complement. It doesn't really matter on this. Okay, because the first thing we do is parentheses. There are no parentheses, but do we have complements? Yes, we do. We have the A complement and we have the C complement. So we're going to work with A complement first, and then we'll do the C complement. So A complement means give me everybody not in A. So all the numbers not in this circle A are 2, 5, 6, and 7. 2, 5, 6, and 7. Down here, this says C complement. So I need all the numbers that are not in C. So not in the green circle are 3, 6, and 7. All right. Now we deal with union intersection, and we have union. Union means give me everybody. So between these two sets, I want you to write all the numbers down. So who do we have in the union of A complement, C complement? We have 2, 3, 5, 6, and 7. And that is the answer. Because these are all the elements in A complement and C complement. Oops, trying to get back up to the top. So 2, 3, 5, 6, and 7. And there you go. That's as tough as what this section's going to get. Okay? I've got one more thing to talk about, and it is when we deal with null sets or empty sets. It's another word for empty set is what we call a null set. So I want you to think about this. So we got this set A up here, and that set A is just the numbers 2, 4, 5, and 6. Now remember, the empty set, this guy, sorry, trying to get rid of this. There we go. No, you don't need my email. All right. Remember, the empty set has nothing in it. Okay? So let's think about these questions real quick. I want A union the empty set. So if I take A union the empty set, I've got 2, 4, 5, and 6. Okay? Union means give me everybody. And in the empty set, I have nothing. So what happens when I take 2, 4, 5, and 6 and add it with nothing? Because remember, I just combined these two. All I do is I get the original set back out. It's like you're adding 0. It's like you're adding 0 here. So if I take A union the empty set, I just get my set A back out. All that I'm doing is I'm keeping the same numbers. 2, 4, 5, and 6. Because there's nothing in the empty set to union with. Okay? Now let's think about the other one. A intersect the empty set. So what do set A, which is 2, 4, 5, and 6, and the empty set have in common? Hopefully you said nothing. So A intersect the empty set is just the empty set. So hopefully what you kind of found here in general, if I take any set, doesn't matter what set it is, union the empty set, I get that beginning set back out. It's like adding 0. If I take any set that I want and intersect it with the empty set, I get the empty set. Kind of like a multiplying by 0. Because 0 times anything is nothing. So that's kind of like what these are like, kind of if you put operations to them. The union between these two is like adding. The intersection between these two is like multiplying. Okay? If I take anything plus nothing, I get anything back out. If I take anything times 0 or nothing, I get 0 back out. So keep that in mind. Any set union a null set or empty set is the beginning set. Any set intersect the null set or empty set is the null set or empty set in the end. Okay? And that is 2.3. Enjoy.